Hey, Assalamualaikum warahmatullahi wabarakatuh. So here we are at chapter 17. So together there are 7 subtopic to be covered. So this would be our part 1. Alright, looking at the slide, first and foremost, since I can't click this, so I presume that I am asking you to click on your own for you to look at certain experiments, simple experiment that producing interference in terms of sounds. So let's start with the analysis with interference. So basically, when we talk about standing wave or superposition means the ability for the wave to combine themselves, okay, at one particular position, while standing wave is actually a reference to a resonance. Okay, so the what is superposition? If two or more wave traveling through a medium and then they overlaps, so the resultant value of the wave function at that locations where both exist is the summations of the wave function itself. So you add them up, so you are gonna be looking at probably amplitudes will be amplified. So what we find that the whole idea are governed by the idea of constructive and destructive. So what it meant by construct is to add ons. So here is the case where a combinations producing a resultant of interference because they are adding up. Where else a destructive interference is a case whereby both is in the opposite direction. So mathematically, the overall amplitudes where the resultant impulse of the height akan jadi reduce. So observe here in the given figure of 17.1 on the left parts here. So two traveling wave moving towards one another, and at one location they are overlapping, and notice when they are exactly overlapping, the amplitudes will be a total of y1 plus y2, and yet they can separate themselves right after that because moving onward. So this is what it meant by constructive interference. How about destructive? Destructive is a case whereby one is up, one is down. So mathematically, one is negative in terms of the amplitude. So the very moments that they start to overlap, you notice that the net amplitudes get reduced. So the original and the original, okay, and because the positive y1 is much larger as compared to y2, so that's the reason why the net is still y positive y, slightly positive y. So the previous figure is a scenario where the figure is still image. So this is where we have two waves, overlapping with one another, but we put it in a GIF form, keep moving. So you have noticed that the resultant is the A. So the original is coming from the red color and the green color. So when they are overlapped, you notice that they keep changing in terms of the amplitudes. This is another example to show you how two traveling wave travel in the opposite direction and then they start mix up. Okay, so superposition is the case whereby it's mixed up, but it doesn't mean that once it's diminished and it continue diminish. It really depends on the original orientation and direction of the original wave. If it's traveling towards one another, eventually when they meet up, they will recede from one another, meaning pass away from one another, and then they can get separated. So wave can be separated. So the whole idea of this one as well, when we bring it into up higher level, so we can have sounds separated from likewise, if we are in a forensic and then there was this video, a mixture of sounds, so we can separate the sound, and in fact to the extent we can remove the background noise and such. And to remove the background noise means that we can remove noise from our recording as well. Right, quick quiz 17.1, okay, to test you on the concept of the constructive and destructive interference earlier. So two pulses, two wave. Pulses is actually another terms used to refer to wave. move in opposite direction on a string and are identical in shape and also in size. So they are having the same amplitudes. However, one has positive displacement, one is up, and the other has negative displacement in the opposite direction. So, such. Now, at the very moment that they overlap, what happens? So, what happens? The energy disappeared, the string is not moving, the form. Okay, let's start with the common one. So, they will form a straight line. Right, let's visit the idea of superposition of sinusoidal wave. Now, the given figure here shows an example how the superposition occurred in two ways. Number one, you will be able to hear the sound, and you might not be able to hear the sound. How? Now, the upper parts of the hose here, the pipes here, is movable. So basically, you can move it up and down. So by moving it means that you're going to change the distance from P and towards Q. So by changing the distance, by measuring the path difference here represent R1 minus R2. If the answer in certain manner, you're going to get that there's no sounds coming out. Why? Because the sound that gets into at P and then gets separated into two position, upper and lower parts, and then recombine at Q, somehow meet with a situation where there's a crest and meet with the trough at that location. They are in opposite direction. Because they are opposite direction, basically the net would be 0. So that's the reason why the ear would not be able to hear. But if the distance is changed to the concept that the resultant wave at Q is both in the same traveling in upwards direction, so you're going to hear much louder sound at the location of R. So I suggest that you look at the given YouTubes to really understand the concept of what being discussed over here. Now, continuation of the idea of the two wave that travel and superposition themselves at a certain location. So basically, we will be very interested to know what will be the resultant wave at that location itself. The general and expression for that is 2a cos psi over 2 sine kx minus omega t plus psi over 2. Now, the takeaway notes of this concept is the product of amplitudes of the two resultant wave would be the whole product from 2a over here before the start of the sine. Remember that when it involves omega t, this is already the function of sine. But before that, which is a product of 2a cos psi over 2, this is the amplitude. Whereas the phase constant itself is the psi over 2 itself. So the wave functions when two waves travel together when they have same direction, same frequency, same wavelength, and amplitude. However, they are differ in phase. Now, the last slide said something about that it's differ in phase. So this is an example whereby it's in phase. In phase, they are equivalent. You naik, I naik, you turun, I turun. Okay. So observe that the amplitude is still a product of 2a cos psi over 2, right? And this is a scenario whereby constructive occurred. And constructive occurred because of the amplitude add-ons. So they are the blue color, there are two blue waves, the individual waves. So there are S here. So there are two waves that have the same size and shapes, right? And therefore they are indistinguishable lah. However, when they meet up with one another, blue meet with another blue, okay, at this location, so they total up and becomes larger, resulting the red color or the brown color of wave, and the product of amplitude is 2a cos psi over 2. Right. So you have noticed that path difference for this case is equivalent to a solid of integer. And the product of cos psi over 2, okay, this product is equivalent to a an integer of plus minus 1. So therefore, in order for the cost product to be equivalent to 1, then the angle, yeah, should be 0 to pi 4 pi. Jadi in conclusion, the whole product of 2a cos psi over 2 is actually just 2a, 2 amplitudes. Now, this is an example whereby superposition occur, yet the resultant is disruptive. So the wave just cancel out themselves. So we call these two versions of the wave are as 180 degree out of phase. You kat atas, I kat bawah. So net kita mesti kosong macam tu. So basically, when we have disruptive occurred, means that the product of resultant wave should be zero amplitude. So cos psi over 2, there are 2a cos psi over 2 equivalent to 0. And therefore cos psi over 2 should be equivalent to pi, 3 pi, 5 pi. To satisfy these forwards means that delta r will turns out to be an odd numbers 1, 3, 5 divided by 2. Then we are going to observe a situation whereby system undergoes disruptive interference. Alright, this is a scenario whereby the two wave does not neither have constructive or destructive. Why? Because they have differences in odd angle, 60 degree here. So general case wave have same wavelength but different in amplitudes, and in phase amplitudes of the resultants is equivalent to amplitudes of the two wave itself. Right, let's have a look at resonance, okay, of what we have seen earlier, and we have to bring it as the foundation to understand what it meant by standing wave. Standing wave is another version or another name to indicate concept of resonance. Now, we have over here sounds coming out from two speakers, given as in the figure. So the first one and the second one looks like this. Okay. Since they are traveling in the opposite direction, we're going to observe that the omega t is different in terms of the direction. So when they meet up, what's going to happen is they're going to add ups, y1 plus y2. So the expression going to be adding up. So when we add sign product A plus minus B, and the answer should be sin A cos B plus minus cos A sin B. Now, for this version onwards, this is only for explanation. It will not be tested during the exam. What's tested during the exam is the product of the two waves when they are traveling in the opposite direction as such should be a product of 2A sin kx cos omega t, meaning that 2A sin kx is the product of their amplitudes. Alright, let's study the concept of standing wave. If not mistaken, the figure is taken for element of the string. We are going to have wave on a string later in the lab, so you would be having the you're going to have this experiment run and observe it yourself. So to look at this figure. So this is the still image, this is the moving image, but this is not exactly yet reaching standing wave resonance. So idea dia adalah when the wave now travelling resonance, standing wave occurred, and you would be observing continuously as if it's still, but yet in the form of the shape as such, segmented shape. Originally, the string is just one straight length, but now it's continuously look as if made of segments, and you can place your hand at the notes here on top of the notes, and you can even see that there's no movement at all on the string. However, on the anti-note where we call amplitudes, okay, we're going to see it's stand up. So position of this for notes, it's occurred at k times x equivalent to 0, and therefore the angle should be pi, 2 pi, 3 pi and onwards. However, for anti-notes, it's occurring at a product of kx equivalent to pi per 2. Okay, 3 over 2. All the odds number. All the odds number. Right, and therefore x is lambda over 4. Right, now don't this is something that you can observe on your own. So observe that the antinode is over here. One wavelength is from the left towards the right. Means that position of the antinode is 1/4. 1/4 pecahkan 4 dapat 1/4 dan juga 3/4. 3 over 4. 5 over 4. 7 over 4. So the n of this, n times lambda, or the numbers, the integer disappeared now. We are going to replace with an unknown as n. So it should be 1, 3, 5, 7, 9 and onwards. Yeah. Right. How about nodes? Nodes will be appearing half of the lambda. Now, the study of descending wave goes deeper into understanding the lambda. Okay, so notice that the antinode is positioned at the maximum amplitudes, while the nodes is at the minimum disruptive position. This is constructive position, this is disruptive position. Recall again that the concept is antinodes, the waves simply meet up in a version of in phase, while at the nodes they meet up dalam situation out of phase. So you're going to see that these shapes of stationary and standing, look, dia macam berdiri, okay, would be made available. Memang you masuk lab, you can observe this scenario. Right, first and foremost, from this figure, we're going to look out for the lambda. So you're going to see that the lambda is a product from the left end until the right end. So you nampak bentuk dua cups. Yeah? So if the question is asking what will be the distance between adjacent antinodes. So from here to here is actually half of the lambda. Half of the lambda. Ini tak cukup. Now, the distance between adjacent nodes, between here to here, is also half a lambda. So it's quite clear because a lambda is from nodes and then goes to the other nodes. So if it's just nodes to nodes, it's half of the way. So that's why it's lambda over 2. So same goes as antinodes earlier. So distance between nodes and adjacent antinodes. So they were referring to this position to this position. This is only 1/4, 1/4. So try to imagine that we crack it into 4 portions. So this is 1 over 4, another 1 over 4, another 1 over 4, another 1 over 4. So altogether, for this portion, distance between one another, next to one another, is all called as 1/4 of the lambda. Now let's have a look at example 17.2, formation of standing wave. However, it's not meant for nursing. But then again, it's not that tough. Okay. So the first question is not that tough. The second question, yes, a little. Alright. So what we are looking at is there are two traveling waves that opposite in direction. Since they are opposite in direction but identical, you will find they have the same amplitudes, the same omega, period the same. However, their traveling direction is different. So those to the right akan ada negative, to the left akan jadi positive. Now, find amplitude. So amplitude from the generic rules when they are add ups is 2a sine kx. Sine kx, right? However, this is the amplitudes of the antinodes. Okay, the question is asking you during or at location 2.3 centimeter. So you are not so sure whether at that position is at what location. Okay, so earlier the graph looks like segment. So 2.3, you have no idea at which location. So that what will be the height at that position. So that's what it's asking. So based on this expression, what we did is we substitute the x given 2.3. So since it's 2.3 centimeter, so your final answer should as well be centimeter. Amplitude should as well be centimeter. So everything should be synchronized. Yeah. So accordingly, if you put in the number of 2.3 earlier, you are going to arrive with answer 4.6 centimeter. Now the next question, you have to find position for nodes. Okay. When x is equivalent, if one end of the string is x equivalent to 0. You should find as well position of antinodes as well. Okay, how do we work out from there? Okay, let's start with position antinodes and nodes. Now, nodes should occur at half of the lambda. Half of the lambda we have discussed earlier. Okay, half of the lambda. While antinode will occur at a quarter of the lambda. Okay, so meanings to say we need the lambda. Where do we get the lambda? Lambda come from the K product. So what is the K product earlier? K product is equivalent to 3. Observe here. K is 3. Okay, K is 3. Now from K equivalent to 3 to pi over lambda. Okay, simplified, you're going to get 2 pi over 3. Now from 2 pi over 3, what we did is we substitute into lambda over 2. So by substituting, we are arriving with lambda over 3 times n. Since to satisfy the situation of is a half, okay, so it can be 0, it can be 1, it can be 2, it can be 3. Okay, right. In the case of the antinodes, okay, it must be 1/4 of the wavelength. So 1/4 of wavelength, substitute the wavelength itself just now. So it becomes pi over 6. And n should be 13579 from the previous slide. So make comparison on the understanding, yeah? On the understanding.